Hello everyone, welcome to my channel. Today we're solving lowest common ancestor of a binary tree. So we're given a binary tree and we're going to find the lowest common ancestor of two given nodes, P and Q in this case. So for example, if we have 5 and 1 as P and Q, the lowest common ancestor will be 3. And in another example, we have 5 and 4 as P and Q, and the lowest common ancestor is 5, so we're going to return that. So the way we're going to solve this is we're going to do an operation for each node using recursion. We're going to have some conditions, and we're going to make it so that the root function or the original function will return the lowest common ancestor. So in this case, the first function will return 3. And we're going to have some conditions. So first one, if root is either P or Q, we're going to return P or Q. So for example, when we're at function 5, it is P, so we're going to return 5. And same as 1. So we're going to return 1. And we're also going to have a base case, so when the left and the right are both no, we're going to return no. So for example, here, if left and right are both no, it doesn't have any left and right child, so we're just going to return no. And this will return no as well. And if the left and the right are both not no, then we're going to return the root. So for example, we return 5 and 1 here for left and right function, so they're not no. So in this case, we're going to return the root, which is 3, which is exactly what we want. And another condition is if the left is no but the right isn't. So for example, in this case, 6 will return no because left and right of 6 is no. Here 4 will return 4 because that's P. 7 will return no. So in this case, a left of 2 is no and the right of 2 is 4. So only one of them is no, so we're going to return the one that's not no, in this case 4. And in this case 5 is P, so we're going to return 5. And here we'll have no, it's the last condition. If the right is no but the left isn't, we're going to return left. So whichever is not no, we're going to return in this case left. And that's exactly what we want. The lowest common ancestor for this example is 5. Alright, so let's actually solve this problem. So first thing we're going to do is we're going to have a base case. So we're going to do recursion calls, so we need to have a base case. And we can check if the root is no. Root is going to be no when it gets to the end of the tree. We can also check if the root is P or Q, which are the nodes that we are looking for. So our root is equal to Q. Then we can just return root, which will either return no, P or Q. And next we're gonna traverse down the tree to the left and to the right. So we can start from the left. So we can have a variable tree node left. We can call the function again, lowest common ancestor. And the argument would be root.left, and P and Q will be the same. So then we can traverse down the right next. So we can kind of just copy and paste this, and we're going to call it right, and the argument would be root.right. So after that, we can check all these conditions that we have. So first one was if the left and right are both no. So let's see, if left is no and the right is no. In this case, we're gonna just return no. So return no. And the next condition was if the left is no but the right isn't, we're gonna return the right. So we can check that down here. So if left is no and the right isn't, then we can just return right. And the same thing for if the right is no but the left isn't. So if the right is no and the left isn't no, then we can just return left in this case, because the left isn't no. And lastly, if you go through all these conditions, then the only condition left will be if the left and the right are both not no. So they both have values. Like here for 3 in this case, it will have 5 and 1. And in that case, we want to return the no, or the root node. So we can just return root here. Alright, so that's basically it. Let's check if this works. Alright, so this was the lowest common ancestor of a binary tree. Thank you for watching.